Fluid means which can flow. That means, say, because of that, we created the name fluid. So fluid means which can flow. What are the things which can flow here? Can you remember? Can you think of? Water. All liquids will flow. All liquids. Not only that, all gases also flow. Therefore, all gases and all liquids combined together have a common name, fluids. So gases as well as liquids will be called collectively as fluids because both of them have the property of the flow. So with this, they have one more very special property. So what is that property which we want to learn? Because of that, they are a little bit different from other solids. So what is that property we want to think of? Just observe. Say, if you have a container of water, I usually take water for as an example because that's what we use every day and we are comfortable with that. That's why. Say, whenever we push our hand into the water or whenever we keep some substance in the water, anything will do. Then water molecules will hit the water surface. They hit the surface in contact. Not only that, even now, when you are sitting in the room where you are looking at this, say gas molecules are hitting continuously on your body. And because of that, they create a force. Because of that, they create a force. Now, what is the direction of that force we want to learn? What is the direction of that force we want to learn? In fact, an astonishing fact, whenever you are in a fluid or whenever the object is in a fluid, it always exerts a force in a perpendicular direction to the surface in contact. Always. It always exerts a force in a perpendicular direction to the surface. That's observe. It exerts like this. It exerts like this, like this. Always it is perpendicular. Always it is perpendicular. So like that. So why it is perpendicular? How do we know it is perpendicular? We are simply saying like that it is perpendicular. Can you agree that? We have to think of that. Can we agree with that? ಯಾರೋ ಪುಸ್ತಕದಲ್ಲಿ ಅವತ್ತು ಹೇಳಿದ್ದಾರೆ. Can we agree that? Can we not see that practically? We want to see that. Now, it is perpendicular. We want to prove logically perpendicular. For that, there's a beautiful idea what I might have said long back in Laws of Motion chapter. But observe, I will tell you now. I told you this usually. Say on a floor, you are walking. On a floor, you are walking. And it is slippery. Say, very slippery floor. ತುಂಬಾ ಜಾರ್ತಾ ಇರುತ್ತೆ ನೆಲ ಅಥವಾ ನಿಮ್ಮ ಮನೆಗಳಲ್ಲಿ ಮೊಸೈಕ್ ಫ್ಲೋರಿಂಗ್ ಇದೆ ಅಥವಾ ವಿಟ್ರಿಫೈಡ್ ಟೈಲ್ಸ್ ಫ್ಲೋರಿಂಗ್ ಇದೆ ಮನೆ ಒರೆಸಿರ್ತಾರೆ ವೆಟ್ ಮಾಪ್ ಆಗಿರುತ್ತೆ ವೆಟ್ ಮಾಪಿಂಗ್ ಮಾಡಿರ್ತಾರೆ then you are supposed to go from one room to another room on that wet say floor. How do you walk to avoid slipping? Always without knowing the actually idea, physical idea behind that, all of us walk like this. I write like this. If this is the thing, step on step. We don't keep our steps in normal way. ಹೆಜ್ಜೆ ಮೇಲೆ ಹೆಜ್ಜೆ ಇಟ್ಟು ನಡೀತೀವಿ ಮಕ್ಕಳು. ಇಲ್ಲೊಂದು ಹೆಜ್ಜೆ ನೆಕ್ಸ್ಟ್ ಹೆಜ್ಜೆ. ಆ ಹೆಜ್ಜೆ ತೆಗೆಸ್ಕೊಂಡೆ ಇನ್ನೊಂದು ಹೆಜ್ಜೆ ಇರುತ್ತೆ. ಹಾಗೆ ನಡೆದ್ರೆ ಯಾರು ಬಿಡಲ್ಲ. ಅದೇ ನೀವು ನಾರ್ಮಲ್ ಆಗಿ ಈ ಕಡೆ ನಡೀತಿರಲ್ಲ ದೂರ ಕಾಲ ಹಾಕೊಂಡು ಆ ತರ ನಡೆದ್ರೆ ಡೆಫಿನೆಟ್ ಆಗಿ ಜಾರ್ತೇವೆ ನಾವು. ಯಾಕೆ ಹಾಗೆ? ನಾನು ಇದನ್ನು ಹೇಳಿದ್ದೆ ಬಹುಶಃ ಲಾಂಗ್ ಬ್ಯಾಕ್ whenever we thought of force and other things in the laws of motion chapter. Now we think of once again. Nodi, in this case, when we keep our steps on step, we exert almost a force on the floor normally. But when we keep our leg in normal manner, that is in a normal walking style, we exert force on the floor in an inclined manner like this, what I have written here. Now, observe the idea carefully. And this is also a beautiful proof for there is the existence of components, physical components, force components are real in nature. That we know, that we came to know from this. Because we said force can be resolved into 2 or 3 components. We all said. But using these ideas and what we learned today, we literally know physically in the physical world also, it's not only in the mathematics components, it exists in the real world. How? We are witnessing now. Observe here, when the legs are almost perpendicular to the floor, there's no component of this force in this direction because it's completely along the y-axis. Only when a force or vector is along the one axis, other component is 0. We know that. Therefore, it is perfectly along the y-axis, vertical axis. So no x component, no horizontal component for this. But for this case, if you write, what will happen? Say, this is, if this is F, we call this as F horizontal component. And then this is vertical component. That means whenever we keep our step in a normal, say, in usual walking style on the floor, slippery floor, we exert a force at an angle with the floor, say some theta there. Then that makes that force to have the 2 components. That force to have 2 components, one parallel to the floor, FH I call horizontal, one vertical to the floor, FV I call. Observe carefully now. Because of this, FV supports our weight, but FH pulls your leg forward because it's slippery floor. FH pulls your leg forward, there's all chance of you are slipping, you will fall. So observe, this is a beautiful physical proof for existence of the components in the nature. There's another beautiful proof in the sky. What you learn in the second year, say in the near polar regions, in the Australia, in such regions, we see spectacular, colorful display in the night sky of the earth. In the sky of the earth, in the sky, we see beautiful, spectacular display of the colors. And that is called as auroras, actually, aurora. One that occurs near Australia, that is in the southern hemisphere, aurora australis, and in the northern sphere, aurora borealis. They are the spectacular, colorful display in the sky of the earth, that near the polar regions, extending up to kilometers together. But even, can you believe that spectacular, colorful display is created because of the charged particles entering into Earth's magnetic field at an oblique angle like this. That is, again, there is a proof for the existence, real existence of the components of the force or components of the other things. Vector has components, that is not only the mathematical idea, physically we are seeing it now. Observe, because that is one more extra idea what I told you, that you learn in the second year, how the auroras are created, how they give you so much of color in the night sky. That's secondary. Now, coming back to this fact, observe, this is a beautiful proof of any vector can be resolved into 2 components. Physical proof. Here, One who knows the physics or not knowing the physics. Nature do its work. Nature pulls the leg forward because of the force oblique. That clearly proves there is a component action there, part action. That is, a part of F pulls your leg forward, a part of F supports you over the floor. So this is the idea. Can you believe, using this idea, we can prove fluids always exerts force on the surfaces in contact. That force is always perpendicular. We can prove that by using simple idea like this. How? We want to see. Say, what we want to do now, we want to show whenever we dip our hand into the water in any inclined manner, the water exerts force on our hand, always normal to the, whatever may be the shape of the hand. We can make it like this. Even at this, it is normal. At this point, it is normal. At all points, it is normal. How it is possible, that we can explain now. Observe carefully. We'll do it. Most probably, many of you got the explanation by this time in your head. It should be. Because you're all good, as I used to say. Prajwal, what you are saying is not so much comfortable. No, say, if this is the liquid, this is the surface in contact, some object is immersed. Now we are saying the force is acting normal. If it is not normal, what should happen? If it is like this, the force, then as we said, there are two components. One parallel to the surface of, I call it as F double line. Double line means parallel. And one perpendicular to the surface like this. F perpendicular, right? This should be the case. If force is not normal, if the force F is not normal to the surface in contact with the liquid or the fluid, this should be the case. F parallel should act to the parallel to the surface and F perpendicular act perpendicular to the surface. If that is the case, what is the consequence? Can you think of? Prajwal said object has to move. No, object cannot move. But basically, the fluid should flow on this. Because of the force, fluid should flow. That means when you dip your hand at an oblique angle to the water, you must create a continuous flow of water on your hand. Is that possible? Once we dip in our hand into the water, ಸುಮ್ಮನೆ ಇಟ್ಕೊಂಡ್ರು ಕೈನ ನಿಮ್ ಕೈ ಮೇಲೆ ನೀರು ಹರಿತಿರ್ಬೇಕು. ಹರಿಯಕ್ಕೆ ಸಾಧ್ಯವೇ ಇಲ್ಲ, ಹರಿಯೋದು ಇಲ್ಲ, ನಾವು ನೋಡಿಲ್ಲ. ಪ್ರಾಕ್ಟಿಕಲಿ ವಿ ಹ್ಯಾವ್ ನಾಟ್ ಸೀನ್. ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಈ ಎಫ್ ಪ್ಯಾರಲಲ್ ಕಾಂಪೊನೆಂಟ್ ಇಲ್ಲ. ಇದ್ದಿದ್ರೆ ಹರಿಬೇಕಾಯ್ತಲ್ಲ. ಎಫ್ ಪ್ಯಾರಲಲ್ ಆನ್ ಅವರ್ ಹ್ಯಾಂಡ್, ಸೊ ದಟ್ ವಾಟರ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ಅವರ್ ಹ್ಯಾಂಡ್ ಆಲ್ಸೋ ಶುಡ್ ಫ್ಲೋ ಆನ್ ಅವರ್ ಹ್ಯಾಂಡ್. ಇಟ್ಸ್ ಇಂಪಾಸಿಬಲ್, ವಿ ಹ್ಯಾವ್ ನಾಟ್ ಸೀನ್ ಇಟ್. ಇಟ್ ಪ್ರಾಕ್ಟಿಕಲಿ. ಅದರಿಂದ ಏನರ್ಥ, ದೇರ್ ಇಸ್ ನೋ ಕಾಂಪೊನೆಂಟ್. ಎಫ್ ಪ್ಯಾರಲಲ್ ಇಲ್ವೇ ಇಲ್ಲ. ಎಫ್ ಪ್ಯಾರಲಲ್ ಇಲ್ಲ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಫೋರ್ಸ್ ಕೆನಾಟ್ ಆಕ್ಟ್ ಲೈಕ್ ದಿಸ್. ದೆನ್ ಹೌ ಇಟ್ ಶುಡ್ ಆಕ್ಟ್? ಓನ್ಲಿ ಅದರ್ go is normal. Only it acts along the normal. How? See how beautifully we arrived at the proof of force is normal. Very beautiful proof. No mathematics, nothing. And also this generated us one beautiful idea. Again, force have components. Again, it is physically proved. That's why I always wonder to see this type of things. Many times, many teachers say, mathematics is the language of physics. But as Richard Feynman say, once you have learned physics, you must be able to explain the physics to a layman without, say, one who doesn't know mathematics, without using the mathematics. So one such idea is here. ನಮಗೆ ಕಾಂಪೊನೆಂಟ್ಸ್ ಅನ್ನೋದು ಲೋ ಕ್ಲಿಯರ್ ಕ್ರಿಯೇಟ್ ಮಾಡೋದು ಮೋಷನ್ ಇನ್ ಪ್ಲೇನ್ ಚಾಪ್ಟರ್ ನಂಬರ್ 4 ಅಲ್ಲಿ ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ಮೇಲೆ ಅದೆಲ್ಲ ಬಳಸ್ತಾ ಬಂದು nobody among you asked me, sir, is that real? Now we are thinking of 100% components exist in nature. ನಮಗ್ ಗೊತ್ತಿಲ್ಲದೆ ಇರ್ಬೋದು, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ನಾವು ಅದಕ್ಕೆ ರಿಲೆವೆಂಟ್ ಆಗಿ ಕ್ರಿಯೇಟ್ ಮಾಡಿರ್ಬೋದು. ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡೋಕ್ ಮುಂಚೆ ಅದು ಫಿಸಿಕಲಿ ಪ್ರೆಸೆಂಟ್, ಅದನ್ನ ನೋಡ್ಕೊಂಡು ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡುದು ನೋಡಿ. ಅದಕ್ಕೆ ಮೊನ್ನೆ ನಾವು ವಿ ಆರ್ ಡಿಸ್ಕಸಿಂಗ್ ವಿತ್ ಪ್ರಜ್ವಲ್ ಕೌಂಡಿನ್ಯ ಅಂಡ್ ದೀಕ್ಷಿತ್, ಮತ್ತೆ ಇಲ್ಲಿ ಸೂರ್ಯ ಪ್ರತೀಕ್ ಎಲ್ಲ ಇದ್ರು. ಅವತ್ತು ನಿಮ್ಗೆ ಕೇಳಿದ್ದೆ ನಾನು, ವಾಟ್ ಆರ್ ದಿ 3 moments where the creative thinking of human beings rise to the topmost extent? ಎರಡು ಹೇಳಿದ್ದೆ, 0 ಒಂದು, wheel ಒಂದು ಅಂತ. ಇನ್ನೊಂದು ಯಾವುದು, ಈಗ ಇದನ್ನು ತಗೋಬಹುದು. ಯಾಕಂದ್ರೆ whole lot of mathematics, especially what we use in physics, created to explain the physics what is already there. ಅದನ್ನೇ ಇದನ್ನ ಟಾಪ್ ಮೋಸ್ಟ್ ಕ್ರಿಯೇಟಿವಿಟಿ ಅಂತ ಹೇಳಲ್ಲ ನಾನು. ಆದ್ರೆ ನಾವು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ವೆಕ್ಟರ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಎಲ್ಲ ಬರೆದು ನೇಚರ್ ಅದು ಆಗ್ಲೇ ಇದೆ, ನಾವು ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಅದನ್ನ ಯಾರು ಯಾವತ್ತು ಈ ವೆಕ್ಟರ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ವೆಕ್ಟರ್ ಎಲ್ಲ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಅನ್ಕೋಬೇಡಿ, ಅದೆಲ್ಲೂ ಇಲ್ಲದೆ ಇರೋದು ಅಲ್ಲ ಮಕ್ಕಳು. ಪ್ರತಿ ದಿವಸ ಅದಿದೆ ನಮ್ ಜೊತೆಗೆ. ಆದ್ರೆ ಅದನ್ನ ಕಾಣೋ ಕಣ್ಣುಗಳು ಬೇಕು. ಈ ಆಧ್ಯಾತ್ಮದವ್ರು ಹೇಳ್ತಾರೆ ದೇವ್ರೆಲ್ಲ ನಿಮ್ ಜೊತೆನೆ ಇದ್ದಾನೆ, ಆದ್ರೆ ನಿಮ್ಗೆ ಕಾಣೋ ಕಣ್ಣು ಬೇಕು ಅದಕ್ಕೆ ಅಂದಂಗೆ. ನಿಂಗೆ ಇದು ಅರ್ಥ ಆಗ್ಬೇಕು ಅಂದ್ರೆ ವಿ ಹ್ಯಾವ್ ಟು ಅಪ್ರಿಶಿಯೇಟ್ ದೀಸ್ ಸಿಚುಯೇಷನ್ಸ್. ನೋಡಿ, ಪ್ಯಾರಲಲ್ ಇದ್ದು ಬಿಟ್ಟಿದ್ರೆ ಏನಾಗಬೇಕಾಯ್ತು, ನೀರ್ನ ತೆಳ್ಕೊಂಡು ಕೆಳಗೆ ಬಿಡಬೇಕಾಯ್ತು, ಅಂದ್ರೆ ನಮ್ ಕೈ ಮೇಲೆ ನೀರು ಹರಿಬೇಕಾಗಿತ್ತು. ವಾಟ್ ಇಸ್ ನಾಟ್ ಹ್ಯಾಪನಿಂಗ್ ದೇರ್ ಅಂದ್ರೆ ಅರ್ಥ ಇದಿಲ್ಲ, ಈ ಫೋರ್ಸ್ ಇಲ್ಲ. ಹಾಗಾದ್ರೆ ಇನ್ನೇಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇರ್ಬೇಕು, ಇಟ್ ಇಸ್ ಆಕ್ಟಿಂಗ್ ನಾರ್ಮಲ್ for it now. And also we learn an astonishing fact where in the nature, why do we say only spherical drops of the water? Why not the cubical baths, shaped drops? ಯಾವತ್ತು ಯಾರು ಕೇಳ್ಕೊಂಡಿದ್ದೀರಾ ಮಕ್ಕಳ? ಈ ತರ ಕ್ಯೂಬ್ ನಮಗೆ ಡ್ರಾಪ್ ಸಿಗ್ತಾ ಇಲ್ಲ, ವಾಟರ್ ಡ್ರಾಪ್ ಯಾವಾಗ್ಲೂ ಸ್ಪಿಯರ್, ಆಲ್ಮೋಸ್ಟ್ ಸ್ಪಿಯರ್. ಯಾಕೆ ಸಿಕ್ಕತ್ತೆ? ಯಾಕೆ ಈ ತರ ಶೇಪ್ ಸಿಕ್ಕಬಾರ್ದು? ಯಾಕೆ ಪ್ಯಾರಲಲ್ ಪೈಪ್ ಸಿಕ್ಕಬಾರ್ದು? ಶೂ ಬಾಕ್ಸ್ ತರದ್ ಯಾಕೆ ಡ್ರಾಪ್ ಸಿಕ್ಕಬಾರ್ದು? ಎಲ್ಲೂ ಸಿಕ್ಕಲ್ಲ. ಇದೇ ಕಾರಣಕ್ಕೆ ಸನ್ ಮೂನು ಎಲ್ಲವೂ ಗ್ಲೋಬ್, ಆಲ್ಮೋಸ್ಟ್ ಗ್ಲೋಬ್, ಸ್ಪೆರಿಕಲ್. ಯಾಕೆ? ದಟ್ ವಿಲ್ ಲರ್ನ್ ಇನ್ ದಿಸ್ ಚಾಪ್ಟರ್. ವಿಲ್ ಗೋ ಫಾರ್ ದಟ್ ಲೇಟರ್ ಆನ್. ಫಾರ್ ದಿ ಟೈಮಿಂಗ್, ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ. Now we proved a beautiful thing with all these extra things. Whenever any substance comes in contact with the fluid, it is exerted by a force which is always perpendicular to the surface. That's the thing what we proved this morning at this moment. What is that? Any object which comes in contact with the fluid, always exerted by a force by the fluid in a perpendicular direction. Say, on our head, on my head, air is impacting like this. And on my face, air is impacting like this. That's happening. Sir, ಮೂಗೆಲ್ಲ ಹಿಂಗ್ ಕರ್ವ್ ಆಗಿದೆಯಲ್ಲ ಸರ್, ಅಲ್ಲೆಲ್ಲ ಎಲ್ಲ ಕಡೆಯೂ ನಾರ್ಮಲೇ. ಯಾರೋ ಹೇಳಿ ಮಾಡಿಸ್ದಂಗೆ ಅಡ್ಜಸ್ಟ್ ಆದಂಗೆ ಎಲ್ಲ ಕಡೆಯೂ ನಾರ್ಮಲ್ ಆಗಿ ಅಡ್ಜಸ್ಟ್ ಆಗತ್ತೆ ಅದು. Who said it to adjust normal? We don't know. It is happening like that in the nature. Okay. ಯಾವ್ದಾದ್ರು ಕರ್ವೇಚರ್, ಯಾವ್ದಾದ್ರು ಶೇಪ್ ಇರಲಿ ಮಕ್ಕಳ, ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಿಂತ್ಕೊಂಡ್ರೆ ಯಾವ್ದೇ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯಾವ್ದೋ ಒಂದು ಲಿಕ್ವಿಡ್ ಅಲ್ಲಿ ಯಾವ್ದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಬಳಸ್ಬೋದು, ಮುಳುಗಿಸ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಈ ಪಾಯಿಂಟ್ ಹೆಂಗೋ ಇದೆ, ಇಲ್ಲಿ ನಾರ್ಮಲ್. ಈ ಪಾಯಿಂಟ್ ಬಂದ್ಬಿಟ್ಟು ಇಲ್ಲಿ ನಾರ್ಮಲ್ಲೇ ಅದು. ಈ ಪಕ್ಕದಲ್ಲಿ ಸ್ವಲ್ಪ ಬೆಂಡ್ ಆಗಿದೆಯಾ, ಆ ಪಾಯಿಂಟ್ ನಾರ್ಮಲ್ ಅದು. ಅಟ್ ಆಲ್ ಪಾಯಿಂಟ್ಸ್ ಇಟ್ ಇಸ್ ನಾರ್ಮಲ್ ಆಲ್ವೇಸ್. ನೋ ಕ್ವಶನ್ ಆಫ್ ಒಬ್ಲಿಕ್ನೆಸ್, ಇಲ್ವೇ ಇಲ್ಲ, ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗೇ ಇರುತ್ತೆ. ಆಯ್ತಾ? ಈಗ another astonishing fact to be proved by you by using the vectors. ಸೊ ಅಲ್ಲಿಗೆ ನಮ್ಗೆ ಕನ್ಫರ್ಮ್ ಆಗಿದ್ದೇನು, ವೆಕ್ಟರ್ ನೋಟೇಶನ್ is already there, inherently there, built in nature by the components form. Adhan now later on we are converting into our understanding way of writing the mathematics. Vector is always there. ಎಲ್ಲ ಕಡೆ ಇದೆ ಅದು, ಅದ್ರ ಕಾಂಪೋನೆಂಟ್ಸ್ ಎಲ್ಲ ಇವೆ. ನಾವು ಅದಕ್ಕೊಂದು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಬರೆದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಒಂದು ಮೆಥಡ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ ಮಕ್ಕಳ. Okay with that. Now we want to prove we want to define first what is pressure. Till now we said somewhere But what is pressure? It is force exerted by per unit area by a fluid. Unit area by a fluid. Pressure is force exerted per unit area by a fluid. Very simple idea. Say if I have some object inside the water, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟು ಪ್ರೆಷರ್ ಅಂದ್ರೆ how much force is acting on it divided by the area on which you are calculating, F by A. That is what we call as pressure. If you say, and also observe one more important thing, when you dip your hand or when you keep any substance inside the water in a level, pressure is always same. ನೀವು ಕೈನ ಹಿಂಗ ಹಾರ್ಸಾಂಟಲ್ ಆಗಿ ಇಟ್ಕೊಂಡ್ರೆ ಇಲ್ಲಿ ಜಾಸ್ತಿ ಹೋಗ್ತದೆ ಇಲ್ಲಿ ಕಡಿಮೆ ಹೋಗ್ತದೆ ಏನೂ ಇಲ್ಲ ಅಂದ್ರೆ ಈ ಒಂದು ಹೌ ದಟ್ ಪ್ರೆಷರ್ ಇಸ್ ಕ್ರಿಯೇಟೆಡ್ ಆಸ್ ಯು ಸೆಡ್ ಬಿಕಾಸ್ ಆಫ್ ದಿ ಮಾಲಿಕ್ಯುಲರ್ ಇಂಪ್ಯಾಕ್ಟ್. ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನು ಕೈ ಮೇಲೆ ನೇರವಾಗಿ ಹಿಂಗ್ ಬಡಿತಾ ಇರುತ್ತೋ when they are impacting, they create the pressure because of the force. They create the force because of that pressure. Observe. That force impacting is always normal. ಆ ಎಲ್ಲ ಮಾಲಿಕ್ಯೂಲ್ಗಳು ಹಿಂಗೆ, ಅದು ಎಲ್ಲ ಕಡೆಯೂ ಒಂದೇ, ಬೇರೆ ಬೇರೆ ಇಲ್ಲವೇ ಇಲ್ಲ ಅನ್ನೋದು ಪ್ರೂವ್ ಮಾಡ್ತೀವಿ ನಾವೀಗ ಪ್ರೆಷರ್. ಹೇಗೆ ಸಾಧ್ಯ ಅದನ್ನು? So we want to prove that now. So pressure is defined as force per unit area, fluid force per unit area. Sometimes we also call as thrust. Thrust. In a new book, NCERT textbook, we have not used word thrust, but in the olden textbook, they used to have the word thrust. Now we use only force per unit area, the pressure. So we go for that now. In a fluid, whatever may be the direction in which you keep the object, the pressure remains same. That means if you consider a point in a fluid, you measure the pressure from one side or measure from top, measure from the left side, right side, or from the bottom. In all the directions, if you measure the pressure at that point, it is always same. That's the proof what we are going to generate now with little bit of components and other things. How to prove that? That's one thing called in our textbook as Pascal's law. Adana prove ಮಾಡಬೇಕು ಮಕ್ಕಳೇ. How do we prove it? It's easy to prove. Only 2-3 line proof. We go for it. Observe. I have taken a container like this. I write down. I have taken a container like this, in which we fill the water. Water ಅಂತಲ್ಲ ಯಾವ ಲಿಕ್ವಿಡ್ ಆಗೋದು ನಿಮಗೆ ನಮಗೆ ಈಸಿಯಾಗಿ ದಿವಸ ಹತ್ರ ಇರೋದ್ರಿಂದ ಅದನ್ನು ಹೇಳ್ತೀನಿ ನಾನು. Water. In that, what I want to prove, at a point, if you measure the pressure from any direction, it remains same. We want to prove. For that, I consider portion of the water. I am going to write a picture there, but it is not something what we must. It is a portion of the water only, portion of the liquid, portion of the fluid. ಯಾವ ತರ portion ಬರೀತೀನಿ ನಾನು? ಒಂದು ಟ್ರಯಾಂಗಲ್ ಬರ್ಕೋತೀನಿ ಮಕ್ಕಳಿಗೆ. ಫಸ್ಟ್ ಐ ರೈಟ್ ಎ ಟ್ರಯಾಂಗಲ್ ಲೈಕ್ ದಿಸ್. ಬೇಕಾದ್ರೆ 3 ಬೇರೆ ಬೇರೆ ಕಲರ್ ಉಪಯೋಗಿಸೋಣ, ಯಾಕಂದ್ರೆ ದಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ ಪ್ರಾಪರ್ಲಿ. 1 2 3. ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ ನಾನು? ಐ ಮೇಕ್ ಇಟ್ ಲೈಕ್ ಎ ಪ್ರಿಸಮ್. ಬಾಟಮ್ ಬಿಲ್ಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಈ ತರ ಆಯ್ತು. This is a portion of liquid. We are not immersing anything. We are not immersing anything. ನೋಡಿ, ಇದು ಒಂದು ಫೇಸ್ ಆಯ್ತು. ಈಗ ಒಳಗಡೆದು ಗ್ರೀನ್ ಫೇಸ್ ಒಂದು ಬರೆಯೋಣ. ಇಲ್ಲಿಂದ we put down there. ಇದು ಗ್ರೀನ್ ಫೇಸ್, ಇದು ಗ್ರೀನ್ ಫೇಸ್. ಅಲ್ಲಿಗೆ ಎಷ್ಟು ಫೇಸ್ ಇವೆ? 3. 1 2 3. Now, due to force, due to fluid water there, there's a force acting on this. I call this as, say, FA, force FA. And we name that ABCD. And area of this surface, AA I call. AA. And this I call as theta, this angle. Now, CDEF I call. And this is another surface on which again force is acting normal. I call this as FB. And this area AB. The bottom surface is there. Here, this is CDEF, CDF here, CDF. And its area, AC I call. AA, AB, AC. I left with 10 more minutes. Within that time, we can conclude. So these are the things now. And remember, what is not said in our textbook, simply they have written. I will tell you now. In physics, area can also be treated as a vector. Area can also be treated as a vector. How to treat that you think of later on. But area can also be treated as a vector where the magnitude of vector is the area magnitude. This area is 2 meters square, if you imagine. We write a vector of length corresponding to 2 meters square. That means with a scale, what we said long back. Like that. Area is also a vector. Now, this overall portion of the water or any fluid for that, it's nothing immersed there. It's portion inside the thing. Portion inside the thing. Inside that, it's a portion of water only. Three forces are acting, FP, and this way I have to write. FC, FA, all are perpendicular. And this portion is at rest. Water is not moving or anything. It is at rest. What is the direction of area vectors? Surya asked me. I will tell you. It's for our convenience. For curved surfaces, it's always outward drawn normal. That means, I will show you. If you have a surface like this, for curved surfaces, area vector direction writing is easy. Say it is a curved surface. This is the normal at this point. So outward drawn normal, this is the area vector direction. But for plane surfaces, it is tricky. How to? Relevant to the sequence, situation, we have to take. Relevant to the situation, we have to take. You observe how I take for the plane surface. All the three planes are, three surfaces are plane. They are not curved. Therefore, we go for it now. How to ascertain? But first of all three portions, say this portion, in fact, of the water is at equilibrium. That means it's not moving. ಮೇಲೆ ಕೆಳಗೆ ಅಕ್ಕಪಕ್ಕ ಎಲ್ಲೂ ಮೂವ್ ಆಗ್ತಿಲ್ಲ ಮಕ್ಕಳು. ಅದ್ರ ಪಾಡ್ಗದಿದೆ. It's neither moving up or down, sideways. ಸುಮ್ಮನೆ ನಾವೊಂದು ಕಲ್ತ್ಕೊಳ್ಳೋಕ್ಕೋಸ್ಕರ ಒಂದು ಶೇಪ್ ತಗೊಂಡಿದೀವಿ, ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೋತಿದೀವಿ ಒಳಗಡೆ. ಯಾವುದನ್ನೂ ಇಮ್ಮರ್ಸ್ ಮಾಡಿಲ್ಲ ಮಕ್ಕಳು. ಅದನ್ನ ಯಾವತ್ತೂ ಗಮನದಲ್ಲಿ ಇಟ್ಕೋಬೇಕು, ಇದನ್ನ ಕಲಿಬೇಕು. ಹಾಗಾದ್ರೆ ಇದ್ರ ಮೇಲೆ ತ್ರೀ ಫೋರ್ಸಸ್ ಆಕ್ಟ್ ಆಗ್ತಿದೆ ಅಂತ ಹೇಳ್ತಿದ್ದೀವಿ. FA, FB, FC. Their sum should be 0, 100%. You know, we write it. I write the diagram, separate diagram here. These diagrams are not written in the book. They are simply written the final idea there. FC, FB is acting like this. So if this is theta, here we must be able to write the theta properly. This is the inclined surface. So if this is theta, vertically this is 90 minus theta, then what is theta to be written? I write that first. Say this is the inclined surface there, a cut line. So if this is theta, where you write the theta for this? Say we extend this line like this. If this is theta, this is 90 minus theta. Therefore, this should be theta. Is that right? Is that right? This should be theta. I hope all of you are getting. ಯಾಕೆ ಇದು ಥೀಟಾ ಆದ್ರೆ ಇಲ್ಲಿ 90 minus theta. ಇದು ನೋಡಿ ಇದು 90 minus theta ಆಗಬೇಕಲ್ಲಿ ಇದು theta. Okay, with that. Now we write the components of FB. ಏನೇನು ಕಾಂಪೊನೆಂಟು? ಈಗ ಈ ಕಾಂಪೊನೆಂಟ್ ಏನಪ್ಪ? ಥೀಟಾಗ ಆಪೋಸಿಟ್ ಅದು. ಅಲ್ಲಿ ಏನ್ ಬರಿಬೇಕು ನಾನು? FB sin theta I have to write. For theta it is opposite. ಅದಾದ ಮೇಲೆ ಈಗ ಇದಕ್ಕೆ ಹಾರಿಜಾಂಟಲ್ ಕಾಂಪೊನೆಂಟ್ ಬರೆಯೋಣ, ಇದಕ್ಕೆ ಅಡ್ಜಸೆಂಟ್ ಬರೆಯೋಣ. ಈ ಕಡೆಗೆ ವರ್ಟಿಕಲ್ ಕಾಂಪೊನೆಂಟ್ ಇದೇನು? ಥೀಟಾಗೆ ಅಡ್ಜಸೆಂಟ್ ಅಂದ್ರೆ ಏನ್ ಬರಿಬೇಕು? FB cos theta, FB sin theta, FB cos theta. So as this portion is at rest, what is the equation of equilibrium? This should be equal to this, this should be equal to this. Therefore, I write FB sin theta equals FA and FB cos theta equals FC. FB sin theta equals FA, FB cos theta equals FC. In the same manner, by taking the area vectors, in fact, in your text, in some text, they write AB like that only, and they take the component, whole surface is shifted like that. They take the component, but we take area as the vectors. So area vectors can be taken in the same direction. Where FB is there, inward down normal, you can take, that is AB area. Where FA is there, AA area vector. Where FC is there, AC vector area. Or else you can take opposite also, because if you want to draw the outward drawn norms like this, even then this relation is valid. The directions are only changed. Therefore, without writing anything, I can simply write, observe, AB sin theta is AA. It should be. And AB cos theta should be equal to AC. Because of the resolution again. That means, how I have written? Observe carefully. Say, AA cos theta, say, AB sin theta is there. AB sin theta means, if you go on pulling it like this area to coincide on this. Say, observe, I said about the projection, no? This is projected onto this like this. Therefore, as this is the angle, this should be sin theta. ಇದಿಷ್ಟು ಏರಿಯಾ ವೆಕ್ಟರ್ ಅಂತ ತಗೊಳ್ಳದೆ ಹೋದ್ರು, ಇದನ್ನ ಇಲ್ಲಿ ಮಾಡಿದ್ರೆ ಈ ಲೆಂತ್ಗೆ ಈ ಲೆಂತ್ ಈಕ್ವಲ್ ಆಗ್ಬೇಕು. ಎಷ್ಟು ಲೆಂತ್ ಈಕ್ವಲ್ ಆಗುತ್ತೆ? AB sin theta ಅಥವಾ AB cos theta ಈಕ್ವಲ್ ಆಗಬೇಕು. ಅದನ್ನೇ ನಾವು ಈಗ ಬರ್ದಿದ್ದೀವಿ. ವೆಕ್ಟರ್ಸ್ ಅಂತ ತಗೊಳ್ಳದೆ ಹೋದ್ರು ಆ ಲೆಂತ್, ಈ ಲೆಂತ್ ಇದನ್ನ ಈಕ್ವೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ cos theta ಅಥವಾ sin theta ಬರ್ಕೋಬೇಕು. That we have it by using the component. You can write this AA sin theta, AB sin theta, AB cos theta by assuming area as vector, first thing. Otherwise, you just imagine this whole area is taken, projected onto ABCD, or this whole area projected onto CDF, CDFE. So then you will get same ideas in either vector form or in the area projection form. Both are one and the same. Now we observe, we achieved a beautiful thing. One beautiful idea achieve ಮಾಡಿದೀವಿ. ಏನದು? We divide the corresponding sides there. We divide the corresponding sides. What we get? Sin theta cancels. FB by AB. What is equal to FA by AA? On this side, FB by AB again. What is there? FC by AC. At once we proved an astonishing result. What can you observe? What is the astonishing result there? ಏನು ಹೇಳ್ಬೋದಾ? ಯೋಚನೆ ಮಾಡಿ. FB by AB, FB by AB, same. Therefore, I can simply write FA by AA, FB by AB, FB by FC by AC. What are all these things? FA by AA, from this side pressure, force per unit area. Force is FA on this side. area is A, force by area is pressure on this surface ABCD. And FP by AB is pressure on ABF or ABFE. And FC by AC is pressure on CDFE. That means these are all the pressures on three different surfaces at three different orientations. One like this, one like this, one like this. What is this proof showing? The pressure are all equal. PA, PB, PC. That is the proof of Pascal's law. There are two Pascal's laws, one for fluid flow, change in the pressure, one for pressure is same. Both are same. I think we proved first one now.